All right, guys, we're ready to talk more about the normal distribution, the bell curve. And example 2, which has several parts, is the exact reverse of example number 1. On example number 1, what happened was they gave us some z-scores and they wanted us to determine areas. So the idea was they gave us z-scores across the bottom here, and we used them to find areas from the table. This time, in example 2, it's backwards. It's the other way around. But let's put a couple of things in place first. You remember that the bell curve is symmetrical, and it's the standard normal z is such that it's a bell curve with a mean of 0, which means that mean 0 is in the middle. And if you were to shade all the area underneath this curve forever in both directions, it would equal 1. And since this bell curve is symmetrical, half of that would be on the upper half of this, 0.5. That's called the upper half. And then this, of course, is called the lower half, and it would also have a shaded area of 0.5. So let's remember those ideas because they will help us on some of these upcoming examples. All right, so looking at example 2.1, it says find the following z value. So we're looking for a score somewhere across the bottom here. So anytime there's a reference to z, to me, in a statistics question, I think, all right, that would be a bell curve with 0 in the middle, okay? And it says that, and it just depends on how it's described, but it says this particular one is above the mean. That would be up here on the positive side. So we already know that that z-score is going to be a positive number, all right? And we're looking for that particular z-score right there. Let's just say I'm looking for that z. Now, it says that 48.38% of the distribution falls between it and the mean. Now, one of the things we have to remember is that the table that I'm asking you to master always wants that middle sliver, the area between the z-score and the middle, the mean. So on this first example, that's actually the type of area that they have described. We also need to realize that the areas that live in the body of this table are in decimal form, and they represent the decimal form of those areas, middle sliver, okay, between a z-score and the mean, between the z-score and the middle. So our goal is to always figure out what that middle sliver is from the question that's given. Right off the bat, it says 48.38% falls between it and the mean. And if you change 48.38% into a decimal, that's 0.4838. And guess what? That is a middle sliver. So this is actually ready-made for the table. And so all we got to do is look in the body of the table for 0.4838. I understand that you probably can't see that on the video, but you, again, have a copy of this in the notes that I uploaded. So if we search through the body of the table for 0.4838, and I know you can't see it there, but 0.4838 lines up with 2.104. So 2.14 would be that z-score, and since it was described as being above the mean, it would be positive. I'm going to put the plus sign there for emphasis. You don't have to, but I think it makes sense that we do that. And that's it. That's the answer to that particular question. So again, one of the few times I can say that I'm normal.